Now we'll take a look at number 11, which is the biggest and longest problem on the review paper. But a big complex problem like this is really just a series of easier problems. You just have to break it into little pieces, little chunks. How do we do this? Well, first things first, I have one object, two objects, three objects hanging from some strings. Those strings go over pulleys and everything is stationary. So here's one string. I'm going to call that tension 1. Here's the other string. I'm going to call that tension 2. The only number that we're given, if we look over here and all the stuff that I've got, is that the mass of this object is 20 kilograms. What am I trying to find in this problem? I'm trying to find out what the mass of the other two objects are. M2 and M3 are my question marks. Now I know right here that I'm going to have these two tensions pulling at different angles on mass number 3. Those angles are given in the problem at 30 degrees and 50 degrees. So we will use these in a little bit. I just want to show you these right triangles, that this tension 1 pulls somewhat upward. That's where this T1y comes in. And it also pulls to the right, which is T1x. This tension pulls to the left. That's T2 in the x direction. And it pulls upward, which is where the T2 and the y direction come from. We use our SOHCAHTOA to try and solve for what those are. That's where all of this comes from. My x's are my opposite sides, so I'm going to use sine to get those. So notice tension 1 in the x is the sine of the angle, which is 30 degrees, times the actual hypotenuse, or the actual force, which is tension 1. And T2x is also the opposite, so that's why that's sine of 50 degrees. The y's are both the adjacent sides of these triangles, which is why they are using cosine for both. Cosine of the angle times the hypotenuse, which is T1 and T2, depending on which one I'm looking at. All right, so let's just take a look at mass number 1. This is a really easy problem to do, actually. Just take a look at the forces. Tension 1 pulls upward, gravity pulls downward. I know that it's not moving, so when I add up my up stuff minus my down stuff, it equals 0, or my up stuff equals my down stuff. Force of gravity is mass times 9.8. Mass is given at 20, so my tension 1 has to equal 20 times 9.8 meters per second squared, or 196 newtons. Now I'm going to use that to take a look at mass number 3, because now I know some numbers here. I know this tension. I know that tension is 196 newtons. Because I looked and solved for T1x, T1y, I know that's sine of 30 or cosine of 30 times T1. And I know T1 is 196. I now know what T1x and T1y are if I want to plug those into my calculator. But let's take a look if I add up my left and right stuff on that middle center mass number 3. Well, what pulls to the right on this? The only thing that pulls to the right is T1 in the x. Is there anything that pulls to the left? Yes, that's T2 in the x. My right stuff minus my left stuff equals 0. Or my right stuff equals my left stuff. T1 in the x has to equal T2 in the x. Otherwise, it would pull either left or right. But they're even. It's a game of tug of war where they are tied. T1 in the x I know is sine of 30 times T1. I wrote all that stuff down up here. T2 in the x is sine of 50 degrees times T2. Again, I wrote that down up here. I just get that stuff from the right triangles. Solving for tension 2, which I can do because I know tension 1. I solved for it a minute ago. So a little algebra tells me that T2, once I plug in my numbers, is equal to 127.9 newtons. Now you might say, that doesn't tell us what the mass is. I know, but it actually is going to help us, and here's how. I know this tension. I know this tension. We've done problems where I have an object hanging from 2 different ropes at 2 different angles before. And actually, that problem, we had to solve for the tensions. It was actually a more challenging problem than this, what we've got to do right now. So if we take a look at mass 3 up and down, what are my up arrows? Tension 1y is up. Tension 2y is up. Force of gravity pulls straight down. So T1y plus T2y, my 2 up arrows, minus my down arrow, force of gravity 3, equals 0. Or my up stuff equals my down stuff. T1 in the y and T2 in the y, those are the cosine of 50 degrees times T2, or cosine of 30 degrees T1, depending on which one I'm looking at. Force of gravity is m times g. I'm trying to solve for m, so I'm going to do a little algebra, divide g over to the left side. That's why it's in my denominator on the left now. And I can plug in my numbers. I know T1 is 196 newtons. I know T2 is 127.9 newtons because I just solved for those. And when I plug into the calculator, I get that the mass 3 is 25.7 kilograms. Now we can finish this up by solving for mass 2, which is really easy to do because T2 is up, force of gravity 2 is down. And I know T2, I solved for it right here. So T2 up minus gravity down equals 0. So my up arrow on mass 2 equals my down arrow on mass 2. Plugging in for mg, I know I can divide g to the other side. So T2 divided by g is going to equal mass. T2 is 127.9 newtons. G is 9.8 meters per second squared. Plug them into my calculator. So I know mass 2 is 13.05 kilograms. I know it was a long problem, but you just got to break it into pieces. This is a simple up and down. This is a simple up and down. And then you just have a couple of angles here. This is where you might get confused. If you have any questions, just talk to me in class.